Recording.
Okay. Well, welcome everyone. Happy New Year. And my name is Yu Ding. I'm a professor at the Georgia Tech. And so we kickstart the collaboration for wind turbine performance quantification. And I prepared a few slides just kind of to tune everyone on what we plan to do for a big part of this year, perhaps. But before I get started, I will let Sarah to tell you about some of the background of the We Do Wind and this collaboration between her and me and this particular space. So Sarah, you want to get started?
Yeah, thank you. Hi everyone. I guess most people know me, but if you don't, then my name's Sarah Barber. I'm from the Eastern Switzerland University of Applied Sciences, where I lead the wind energy team, and I started this We Do Wind idea in order to address the problem of data sharing in wind energy. I apologize if some of you have seen this presentation many times in the last couple of months because you've signed up for different spaces, so I'll keep it relatively short. But some of you are new, so I think it's important to do it. So the idea of We Do Wind is actually a framework, and it's about creating mutually beneficial collaborations. So the picture on the right is showing what we're trying to do. We're trying to actually get people we're trying to get this bit in the middle. So we're actually trying to take into account people and how people may be afraid or worried about sharing data. People have also got needs, and but then we have the data itself, and we have the solutions which use the data. We're trying to combine these three things using We Do Win. And so we're trying to make this so-called We Do Win, this so-called win-win situation, where we the general idea is that we say, okay, the people who own data or wind turbines, have got a load of data coming from the wind turbines, they have a load of data, but they don't necessarily have all the solutions. So the code or the tools to do everything they want. Maybe they don't have time to develop models. Maybe they don't have access to the state-of-the-art solutions. So they have data and they're looking for solutions. And the other way around, we have all these researchers and also people working at companies who are developing all these great solutions for different analyses, but they desperately need data, right? And so this whole idea is to say, okay, this could be something that helps both sides if we get a load of data and provide this data to people developing solutions, and the people with the data can benefit by getting solutions. And so that's kind of the idea. And it's based on this idea of challenges. So somebody who owns data or owns an asset can provide a challenge, and then we can get that solved through lots of different people from all over the world who can take part. You can take part in We Do Wind without paying, you don't have to have a certain qualification, you just need to sign up, as you all have done. And we coordinate it on a digital platform, which I'll show you afterwards, which you should all have access to. And the idea is that we have multiple of these spaces. So there's quite a lot of you here today have already been present in some other challenges and spaces, where at the moment we have about 6 running. Of course, the idea is that we then learn from each other and we benefit from the previous challenges. And they're not separate things. And it doesn't have to be just wind energy. At the moment, we've done it with wind energy, but this idea could be used for anything. So in the wind energy ecosystem specifically, at the moment, we have these 6 spaces existing. I was going to say running, but they're not all running. The first challenge we had a couple of years ago was an EDP challenge, where we looked at fault detection algorithms. We followed that with a challenge from a Swiss company called Wingy, where we did something similar with gearbox fault detection. And the 4 running spaces we have at the moment are the European Academy of Wind Energy Test Turbines Committee space, where we've got quite a lot of data from different research wind turbines from members of the European Academy of Wind Energy, so that they're mainly academic members. They've got a load of data, and we've just launched last year a few different challenges on the topic of controller optimization and various different things. The other space that's running is the Open Data Exploration space, which was formed by Charlie Plumley originally, who was at Cubico, but now he works at Glenmont. And the idea is to use, originally the idea was to use the data from Cubico, which has been released which has been published to look at energy yield assessment and compare different energy yield assessments. We've now expanded that a bit, and we've just started a new challenge about static yaw misalignment. If anyone's interested in that, then please do join that space too. Now we have this space, which I'm going to talk about in a minute. We also have the RTDT space, which is a Swiss company who are focusing on structural health monitoring. So we have a challenge running on how can you use more high frequency data to do different things like modal analysis, and also we have, I think, pitch drive fault detection and things like that. So this space, it was originally formed a year ago by Yu Ding and myself together, and it's all about actually his book that he wrote, which some of you may have heard of, called Data Science for Wind Energy, where he actually, I mean, it's not only a really good summary of all the different, lots of different analysis techniques which are relevant for wind energy, but it also has a load of open data associated with it, which you can work through. And so it's a really good basis for a We Do Wind space. So the idea is that it's kind of open, but at the same time, it's focused on this book. Yu Ding moved from Texas A&M to Georgia Tech recently. I'm sure he can tell you more. But in case you see it written as Texas A&M anywhere, not that you're confused, because I think we've not changed it everywhere yet. And we ran a challenge last year. We started it a year ago, and we ran it until June. And it was called Power Curve Benchmarking, and it involved using this Cubico data I mentioned, which is publicly available. And you actually combined it with his data science lectures, so got some students to take part. Some other people took part as well. Maybe some of you are here now, I'm not sure. But at the end, we had 6 different solutions, which we compared, and we looked at the root mean square error and the mean average error of the different solutions. And we've actually got a paper which we're currently writing, which we're going to present at Wind Europe annual event in Bilbao in March, based on that. And so I'm not going to talk about the details of that right now, but you can actually see it on the platform. I can show you in a minute how to find out more about that. Then we did a survey amongst the people who had signed up for the challenge, what they want to do next. And the general consensus was that they want to do something new. And so we now decided to launch this new, well, it's not actually a challenge. We decided to call it a collaboration, which Yu is going to explain in a minute. And that's what we're going to launch today. So I will hand over to you to tell you more about it. But Yu, at some point, if you can pass back to me, I'd like to talk a little bit more about how to use the Relight platform for people who haven't seen it before. But I can maybe do that after you talk about the new collaboration.
Yeah, that'd be great. Thank you very much, Sarah. Before I get started, I think it's probably a good idea for us to do a quick round of introduction. And I look at the list of names. I think I only know Christine and Florin. And so it's really exciting to meet a lot of new colleagues and friends here. So I probably just read out the name from my Zoom list, which is I don't really exactly know in what kind of order they order that, but if you don't mind, I will just call out your name, and you can say a few words of who you are, where you work, and so forth. So Alex? Is Alex okay, Cicero?
Hello, good morning, everyone, or afternoon if you are in Europe. So currently a graduate student at Applied Mathematics Department at Towson University, and I'm interested in this project not only to refresh my mind in the wind energy scientific topics, but also to use in my deep learning neural network approach to forecast the wind power energy production as a graduate project. So I'm really looking forward to the next steps.
Great, that's great. You know, when I was writing that book, actually, we didn't really spend that much on the deep learning part. So that will be a very good complement to the knowledge we already have over there. Next one, Anoop. If I mispronounce your name, please just forgive me.
No, I think you pronounced it just fine. Hi, everyone. My name is Anup. I'm actually located here in Orlando, Florida. I work as a principal scientist for sentient science, and we actually do a lot of health monitoring, or essentially structure health monitoring for wind turbines. We look at both the aspects, like health of the components, gearboxes, main bearings, generator, and also the performance. I've been involved in building some models and getting some anomaly detections, performance indicators for wind turbines, and pretty excited to be a part of this collaboration. Sounds pretty interesting, because I think the challenge with bringing the data and people and companies together, that's the real challenge out there. So pretty excited to learn and explore this more.
Welcome. Aris?
Hello, hi there from me. I'm based in Scotland, Edinburgh. I work for a consultancy plus operator of wind and solar farms. I'm a senior performance analyst doing performance analytics for wind and solar sites. I'm a team lead also of a small team of data scientists and data analysts who do help on the performance analytics. And I'm relatively new to the platform, maybe a month and a bit. So been introduced into the various initiatives and topics of the We Do Wind. So I'm curious to see how we can contribute and learn from this initiative as well. Thank you very much.
Thank you. Welcome. Arthur?
Hello, everyone. I'm Arthur. I'm a PhD student here at the University of Campinas from Brazil. I'm currently working with deep learning applied for condition monitoring and anomaly detection. And I really like the idea that We Do Wind, it had about joining people, industries, and companies to provide solution for real world problems, because I think that's something that we can really benefit from, to not tackling these simple problems and do something that's very impactful for the industry. So that's it for me. Thank you.
Thank you. Welcome. Chris?
Hello, everyone.
Oh, sorry.
Sorry, Chris, you go first.
Yeah.
You go first.
All right, thanks. Hi, Chris Udell here from Valero. We're based in Switzerland, in Zurich, so not too far away from the We Do Wind headquarters. I'm head of business development here, and we manufacture drones. You can maybe see behind me, if I would get out of the way. We make a drone for inspecting lightning protection systems of wind turbines. And also we can also do thickness measurements of the like as well. So this would be a good opportunity for us to see what data is needed, what we can do to help improve the quality of systems and reliability of wind turbines. So I'm happy to join.
Welcome. Christine?
Hi, so second Chris here, Christian Jonsson. I work for Natural Power with analytics and advisory services, lately increasingly with software development of analysis tools. And I'm intrigued to see where we get with this question. As performance quantifications is something I've come across in a lot of different contexts, and I think it'd be really interesting to see what this challenge bringing us together will bring.
Christian also lead the effort as part of the IEA Task 43 on the cultural and the competition, right? To discuss the open data and the open community, establish the open community. I think it's related. We are focused on one specific topic, but over there's talk about the strategies, how to scale up all this kind of effort for various different kind of topics. Welcome, Christine.
Yeah, that's right. Thank you. Thank you.
Ciro Bezerra.
Hello, yes. So my name is Ciro. I work for DNV. I'm based in Porto Alegre, Brazil, and I'm basically a wind farm, independent wind farm performance analysis. That's what I work with. And well, I'm here to share my knowledge and also learn from colleagues at the industry. So yeah, that's it.
Welcome. Clement.
Hey, can you hear me?
Yes.
Oh, okay. Yeah, sorry. I had a problem with mic. Hi, everyone. Very pleased to meet you all. So I'm Clément Jacquet. I'm working as a senior researcher at the Electrical Power Research Institute. So I focus mostly on wind farm analytics, so trying to learn from the data, either on thematics regarding reliability or performances of the wind assets. So there's a very strong connection between what I do and what this We Doing effort focus on, and also like the collaborative aspect is really at the core of what we do at EPRI, trying to learn from each other, from different partners in the industry. So I'm really excited to see what can come out of it.
Welcome. Ethan Roy.
Hi, yeah, it's Eric here from RES. I'm calling from Gothenburg in Sweden. Yeah, I'm a performance engineer for the Nordic fleet. So ISIN is a big deal for us here. And yeah, I've been following We Do Wind ever since my time at Greenbyte with Penmansheld and Kalmarsh with Charlie Likely. So yeah, I tried to join last year. I got deviated, but this year I'll put a dedicated effort to take part. So it's really good to see you again, Sarah.
Great.
Thanks.
Okay. Next one.
I was wondering where you'd gone. I was wondering why Eric had disappeared. I noticed your absence.
Oh no, okay. I'll make it up to you this year. Cheers.
All right, deal.
Yeah, the next one on my list with the name Vignesh, note taker. I think the note taker probably is not part of the name. Vignesh.
I think that's a bot. I mean, not a bot, but I think somebody
Okay, probably it's not
meeting, but just sends that bot to listen to us and record everything that we're saying and then listen to it
could
later.
be. Yeah. So next one, Florian.
Yeah, hi, I'm Florian. I work at the Eastern Switzerland University of Applied Sciences in Sarah's group, in the wind energy group. And I do everything related to data science, machine learning in wind energy. My current project and focus is graph neural networks of wind farms. And I did recently some turbine performance quantification, but I hope to get more into this topic with this challenge.
So in 2022, Florian, Sarah, and I, with 3 co-authors of the paper. Actually, I don't think we have enough time to talk about that paper today, but in the meeting in February, I think I will spend some time continue to discuss this topic and with reference to that paper. Welcome, Florian.
Thanks.
And next one, Hardy. Hardy Olive. I don't think we can hear you. We can see you are talking.
Is that better? Sorry.
Yeah, right. Yeah.
There you go. Perfect. Sorry, everyone. Yes, hi. My name's Harley. I'm a data scientist with BitBloom here in the UK. I have done work on various tangential problems and things that touch on this, and I'm excited to kind of get involved and see what everyone else is up to and lend some expertise and learn as much as I can as well. I think it's a really interesting problem.
Okay. Thank you. Welcome. Peter Cliff.
Hi there. Hi, I'm Peter Clive, Principal Wind Energy Consultant with Black & Veatch UK Limited. So I'm based in Glasgow, and I've been, very interested in this topic for a long time. Looking at techniques for comparing observed performance to, various baselines that one might adopt to see if you can see, signatures of incipient failure or opportunities for performance optimization and so on. So I'm really keen to see what people have got to say about this topic. Thanks.
Thank you, Peter. Next, Sarah. I think Sarah already introduced herself. And next one, Scott.
Hi there. Yeah, I'm Scott from the University of Strathclyde in Glasgow as well. And yeah, I'm doing a PhD on looking at the yaw control system and how you can use data to improve that. And more generally, I'm interested in generally applying data science to improving turbine performance. So I'd like to get involved with some stuff here.
Well, thank you. Hopefully I didn't really miss anyone. Alex sent a note saying his audio equipment had a little problem, but he dropped the note in the chat. And so welcome everyone. So let me share my screen here. Okay. First, I'd like to again welcome everyone, and also special thanks to Sarah for providing this platform. And she alluded to the past effort we did last year, and since she already gave a good summary of what we've been doing over there, I just want to point it out to whoever is interested in the archive, the challenge. There's a two space, or they call two rooms, and in the Relight platform, and one is called archives, another called resources. And you click on those one, you can see what has been archived, the presentations, the challenge description, and so forth. So I've skipped the detail of the past effort, right? And then jumping to the current activity we plan to do for 2024. We call it the turbine performance quantification collaboration. And again, in order to see the two posts really kind of provide the basic information about this particular collaboration, you go to this room, is called challenges, and then click on that. You will see the top post is called turbine performance quantification collaboration. You click on that, it gives you a full description. Another one is the data set, which the data set we're going to use. Actually, it's an open data set affiliated with the book I publish, and it's open access. But this post also give you a little bit kind of additional description about the data set. And here we label the activity as a collaboration rather than a challenge. It's trying to emphasize the collaborative nature, because this is not really intended to be competition. And also time-wise, right? When we did the power curve modeling challenge, we need to set a kind of deadline for all the team to submit their final result and to be ranked within the other team. So, but this time I want to do things slightly with a bit kind of flexibility, because the end goal for us is really to find out is any kind of a set of method or any kind of single method which can be reliable or robust and can be trustworthy in terms of answer this kind of questions. And if that really takes a little bit longer time, let's just use that time, right? The original goal is maybe we can finish to wrap up the major activity by the end of the summer, first 8 months. But if the time is needed, we will go to the next stage, to the later part of the 2024, right? So what is exactly this collaboration about, right? The overarching objective, as I said it, is really find a good way. And, when we define a good way, it's really accurate, when it's applied to data, it gives you a number which is close to the underlying truth. That's the accuracy, right? Robust, we apply to different kind of circumstances, it will, with a high probability, to give you the accurate number, right? It's not like it works in one of the scenario, doesn't work in the other scenario. And eventually it's a trustworthy, right? You need to have some kind of uncertainty quantification to say, you know, I tell you the improvement is 1%, but I'm highly confident it's between 0.5% to 2%, right? Something with that kind of nature. And to quantify turbine's holistic power performance, efficiency, and also the change in the efficiency, right? And also in the commercial operating condition. Because some of the things can be answered in a lab on a smaller scale. But here, what, especially from the owner-operator's point of view, is more important. They know how the turbine perform and how the turbine, the performance changes over time, and especially after certain kind of technical action being taken. And the next question I put over there is like, you know, there's many different kind of service options, right, to do a turbine upgrade. And but those kind of turbine upgrade really cost money, right? This is one of the advertisement I find online is from the EDF and 3M. Actually, the VG is provided by, if you look very close to that insert, is provided by Smart Blade. I worked with the Smart Blade as well, right? The advertisement said if you do this kind of VG installation, it will increase your AET 1.5 to 3%. And if that did happen, and you're going to get your investment back in 1 to 2 years, right? The question is, how do we know this for sure? I'm not really saying the claim is wrong, right? It's just, you know, can we kind of come down to a method and verification process, eventually say, this claim, it is true, okay? This claim may be missed by a certain margin, right? So the VG, for a lot of new turbines, VG is already part of the blade, the new blade construction. But there's many other kind of service provider to sell different type of performance enhancement method, and LET for the blade age, and some control logic upgrade, the power wash, and you name it. So the list of this part was taken from a 2020 presentation at the American Wind Energy Association seminar. And this is only a sub-list of those things, and we put over there. And when I work with the owner operators, they always ask the question, right? That every single one of the service actually costs money, and which is really kind of the business model for the service provider, which there's nothing wrong with that, right? One of the difficulty for the owner operator, and oftentimes for the OEM as well, is like, how do you know for sure, you know, how much the improvement is going to be after the action is being taken? The difficulty actually rooted in the very fact that the wind energy is a variable renewable energy, right? The variable meaning is fuel input is not controllable, right? Not only the wind speed is not controllable, there's a bunch of other environmental factors. They are the so-called confounding factor, right? So people said, you know, why don't we just do a controlled experiment on the wind turbine? So that way we will know, right? By controlled experiment, you really mean, you know, all the kind of environmental condition is controlled at the same kind of level, and therefore the input is, you know, in a comparable condition, and therefore the output can be directly compared with. Many of the other traditional energy sources or energy production method, like oil and gas, you can certainly do something like that, right? You how much natural gas you input, how much oil you put over there to burn, and then you measure how many electricity you produce based on that same amount of input. For the wind, the same thing for solar, right? They are variable input, so it's not really particularly controllable in the natural environment. It is to some extent controllable in the wind tunnel. But the problem is the wind tunnel is too small, right? If you think about the wind tunnels, people typically use 3 to 5 meters in diameter. The actual wind turbine is a whole lot bigger, right? It's on the order of magnitude difference. Their literature actually recorded when the wind tunnel result being extrapolated, right? Because you are going outside your range, your extrapolation goes to much bigger and the order of magnitude larger than whatever the experiment has been done. And there's a quite bit of uncertainty being introduced, and also introduce the inaccuracy, right? Generally, the lab experiment will indicate a more positive improvement for some of the upgrade options, for example, VG, and which people don't really quite observe in the commercial operation. And so in the commercial operation, this has come down to something people call the natural experiment, right? In the natural experiment, I took this one sentence from Wikipedia. It's an observational study, not controlled in the traditional sense of randomized experiment, right? People use the acronym CRT, controlled randomized test, to indicate the so-called traditional experimental design. So it's really randomized and controlled, but the natural experiment is randomly observed. You don't really get to pick what kind of condition you're going to run your test, or you're going to run your turbine to get the power production. So it happened a lot in social science and economics, right? Because a lot of the policy being implemented, you don't really have the luxury to kind of rearrange the whole society and do a controlled experiment. You just you execute this policy decision and then to see what the society is going to react. But in the meanwhile, there's a lot of confounding factors. You cannot really get rid of them, right? You cannot have the entire condition to perfectly comparable before and after implementing this policy decision. And therefore, this particular field of study, causal inference, or the causality study, really kind of become very relevant. And this word, or this expression, causal inference, refer to a field of study, and which is commonly word in economics and social science. They made a huge impact. Because of that reason, in 2021, half of the Nobel Prize in economics actually was awarded to economists who dedicate their time for doing causal inference analysis of causal relationship and apply to the labor market, right? There, in that particular year, the three economists received the Nobel Prize. One half is to the first economist which do the labor market study, but the second and the third person, they are more methodological contributor, and they were like, how you know for sure, right? You have all these kind of conjectures about the labor analysis, but how do you know certain kind of labor policy will give this kind of benefit to the society, right? And they conducted and developed the causal inference method. In the general sense, I believe the causal inference also applicable to the wind turbine performance because of this confounding factor which you cannot control, to make it very kind of analogous to the social science and economics study, right? And so for this particular collaboration, we want to start with a specific problem setting, right? Going forward, maybe this problem setting can be relaxed and to be consider more complicated conditions, but I thought it's probably a good idea to start with something to well define. That way we on the same page, and therefore we can say which method can address this particular set of questions. The first one is the turbine need to operate in their commercial operating environment, because if it's a smaller, much smaller turbine in the wind tunnel study, those kind of things really kind of invoke a different kind of methodology to solve that. And I believe they have relatively good and verifiable method already, right? So it's not really necessarily this group's interest and expertise can contribute to that. The second part is we concerned about the holistic system level performance instead of a subsystem, right? So in the end, how you're going to quantify the change in the performance and or the performance itself is really the AEP, the annual energy production, right? Because that's kind of the language the owner operator really wants to hear, right? They want to know if you say your turbine is getting better, they will say, how much difference in AEP. And if you say your turbine is deteriorating, they will say how much I'm losing in terms of AEP, right? The last part is also tie back with the very first point. It's like the current, in many of the commercial operating environment, the commonly available data is the SCADA data and the weather environment measurement, right? And there are some of the turbines, they probably have other data, but not all the wind farms, right? There's, to this very day, there's probably existing over 70,000 wind turbines worldwide. And there are newer ones, there are older ones, but this very common set of data is the SCADA data. A lot of people criticize the accuracy or the usefulness of the SCADA data. I understand that part, right? Some of the data measured in wake and other, there are obvious problems. But my experience in working with some of the owner operator is like, they said this is all they have, right? And then they want to ask the question, so with this set of data, however imperfect, can you produce something which is useful to answer the very first question we posed, right? I think we have two choices. Either our answer is like, no, you cannot, because this is really kind of very bad data, garbage in, garbage out, there's nothing you can do about it. Or we can say, however imperfect this set of data is, we can give you some of the useful method with a reasonable useful outcome, but with the caution, like there's a certain kind of degree of uncertainty, depends on how good quality, bad quality of our original data set is. It also pointed out how you improve the data, right? But the improvement of the data is a somewhat kind of different topic. We certainly can discuss that, but at the starting point, I think we like to start with the availability of the SCADA data, and then to answer the question about the turbine performance quantification. The data we're going to use, like I said, was published as part of the book publication, and it has two subsets. One is the simulated data mimics the turbine change in pitch angle adjustment. And because it's simulated, so the true power increase is known. And that way we can just simply verify or compare your answer and with that simulated the outcome, simulated input in the first place, right? Another is physical turbine operating data, the tested data and when VG installation, and the true power increase is obviously not known, right? But there are some historical estimate give a range. I'm not really saying those historical estimate are accurate, right? But it nevertheless give you a range which we can discuss whether or not there's a better estimate and how we can say it is better, right? Now, at this moment, I also would like to call for your help, right? If you have data which can be shared for this purpose, or if you're aware of the open data set can be used for the very same purpose we are doing here, please do share the data or the information, right? Because this is really the true spirit of this collaboration, right? Going forward, this collaboration will be structured through a series of online meetings, roughly about a monthly schedule, right? Sometimes it's like 4 weeks apart, sometimes it's 3 weeks apart, and but generally once every month, always at the 9 a.m. US Eastern time. If you are in a different time zone, please do adjustment, because sometimes I think right now it's 3 p.m. the Central Europe time, but there's a certain month because of the daylight saving time change in US or in Europe or both, but they change at a different time, and so the 9 a.m. is not necessarily always the 3 p.m. over there, but it's always going to be the 9 a.m. US Eastern time, and I released all the date up to August 2024. like I said, if the effort goes on beyond August, and we'll decide the time going forward, right? The agenda for the subsequent meeting will be announced in the week before the meeting. And for the very first meeting, because we try just to kind of set the stage and get to know each other. So I didn't really, other than a reminder, I didn't send anything today. And primarily the meeting is like, the collaborating members will present their findings, the result. We have a discussion, we do something and we'll come back to discuss. Again, we document our understanding and so forth. Okay. And I will like to ask you to register yourself as a participant and through the WeDoWin platform, and you are welcome to submit your result, right? And we don't intend this to be competition, but nevertheless to see different kind of solutions and results and everything. And here, Sarah and I was talking about using the WeDoWin platform, and she emphasized to me very recently to say we need to archive everything in the WeDoWin platform. That actually will make the discussion to be revisited if you need it, and also to have all the information available to the participant. And through that mechanism, what you need to do is either you post create a new post, which you do post a story, or reply to existing post, right? So the reply part is easy, because if you click on the post, there's a button, it's called reply. You just click on the reply. In order to post the new story, you need to first click on that Relight platform, it's called assist. And then when it's a new window appear, and there's two choices. One is called decision, another called story. You click on the story, and that's pretty much it. I think Sarah is going to show you, some of the, how to operate the Relight platform just in a minute. And for the February meeting, I will go over some of the existing methods, including our own method for the turbine performance quantification, and that was going to be part of my agenda. I will always leave some time for discussion and so forth. So with this, I will stop here and let Sarah take over to show you how to operate on the WeDoWin platform.
Maybe we could, thank you. Maybe we could see if anyone's got content related questions. So if you've got questions about how to use a platform, don't ask them now, because I'm probably going to explain in a minute. But if you have questions actually about the content of the new collaboration, maybe you could do that now. Does anyone have any content related questions? You've explained everything so clearly that no one's got any questions.
Well, even you have a suggestion how the collaboration should be run going forward, right? You can let us know now, or you can drop create a post in the WeDoWin platform afterwards.
Yeah, but does anyone have anything they want to ask now?
Not at the moment, thanks. I think I'll have a play with it and see what's inside, and then I might have a better question after that.
Yeah, sure. So what I actually want to start with, please just feel free to ask a question if you're still thinking about it and you think of it in a few minutes. I've done a Mentimeter survey because I'm quite interested how likely it is that you will actually be taking part in this challenge, just so that we can kind of plan what we're doing as well. So that link's in the chat. Did I just send that to everybody? I think I did.
Yeah. Yes.
Yes. Was that yes? Yeah, I just sent it to everyone.
Yes,
Yeah.
to everyone.
So just an indication of it. It's completely non-binding, but like, how do you feel about it? How do you feel about that today? And so I've asked the question, are you intending to participate actively definitely, probably, probably not, definitely not. So I already see 9 answers. Thank you. So most people have written probably, which is really great. We actually have nine people participating. That would be brilliant. So thanks for that. And then I'm going to tell you a little bit about the platform now, because I know it can be a bit difficult at first to get used to it. As you've probably worked out, We Do Wind is a kind of, it's not really a commercial thing, it's kind of an experiment. And so, you know, there's things that aren't perfect. I'm just trying to work out how to get this stupid black bar to go away from the top of my screen where I'm showing my screen, but I can't. Wait a sec. It's really annoying because I can't see the menu bar on my. Does anyone know how to get rid of it?
Should be a top right icon that says view on the very top right of it. And if you click that, you should be able to pop out the floating heads.
The trouble is it's in, so in the black bar, or where?
Yeah, where all the heads are.
There's one that's called view, is there? I don't know one called view.
Yeah, when you hover with your mouse to it, but maybe it's a different setup for you.
It's also in German.
DOS.
Oh, never mind. The solution is that I move everything down like that when I'm trying to. Sorry about this. I'm trying to. It's a completely stupid solution, isn't it? Yeah, that should work. At least I can see the bars now. So most of you probably see when you go to, if you just go to relight.cloud, it usually shows, it's got some strange setting that it shows the last space that you were at if you go to relight.cloud. But you can actually force it to go to the space overview. So if you go to relight.cloud/search, you should see all the spaces that you have access to. By the way, if anyone ever has any login problems, there is a page called, if you put /login, you get back to the login page. And sometimes it throws you out. But you should also all be able to get to this overview page. And if you've signed up for the, so the first thing to see is make sure you've got access to this data-driven turbine performance analysis space. Drop me an email if you haven't. It's kind of a manual process, which involves me going in every day to check and to add people manually. So sometimes this manual process has human-related errors. So it could be that you landed on this invitation, but you haven't actually got access. So if you haven't, let me know by email. But you should also all be able to see this space eventually. And as you already said, it's divided into different categories. And this is basically just a tagging system. So some of these posts or documents or stories are tagged with different words, and depending on the tag, you can filter them. So if you want to see all the challenges, you can click on challenges. You can see the new challenge and the old challenge. If you click on data sets, you just see the data sets that are available, and resources. You can see the book and the Python package and some different things. There's also a getting started document. And if you go to homepage, you get back to, you basically remove all the filters again. And so the important document for you right now is this performance quantification collaboration. We will put a document in which is called the webinars, summary of webinars or something. There was one, this was related to the previous challenge, documentation of webinars. We actually recorded all the webinars and posted them in here. So we'll do that again for this challenge. And so this, if you go to this challenge here, you'll see a description. And you'll find a link to the data set. You'll find a bit of information that you already presented. So the next thing that you have to do is register as a participant, because we have multiple challenges inside this space, right? It doesn't necessarily mean that just because you're in the space, you're going to take part in the challenge. So the next step is to go to this link and add your name if you're thinking of participating. Again, it's non-binding. Nothing's going to happen if you put your name there and and you don't participate. And so if you go there, you'll see an embedded Google Doc, which the external link is here as well, in case you, for some reason, can't see it. If you maybe you're not logged in to Google or whatever, but you can actually add it directly in here if you have access. So you can write your name, and you can write the name of other team members. Actually, if you're looking for people to collaborate with, I don't know why we didn't put this in this time, but if you can also put looking for team members, and if you put yes, then we can try to get you together with some other people if you want to work together with some other people and as part who are also participating. I see Chris and Peter have already done that. Thank you. So that's the next step, and then I just want to repeat what you, or slightly correct what you said about how to use the platform. So one of the ideas is that we keep everything in one place, right? I think many of you have probably participated in different benchmarks or challenges before in your life. And one of the problems is that you kind of lose track of everything, and then it disappears, and then you can't get back to it because you don't know, somebody gave you access a year ago, but they've left the company, and there's a Google Doc somewhere which you can't find anymore. And there was an email somewhere, and there was a Slack channel, and it all gets distributed. So we're making an attempt to keep everything on the platform, which means we're putting the recordings onto the platform. But if you have like questions, the first thing you'll probably want to do is send me or you an email. But I actually like to encourage you not to do that. And instead, if you have a question directly related to this challenge, you can click on questions. This is also new, this function. And you can actually then just write a question. So, I mean, I can do it now. I have a question. And then, okay, it's not loading right now, but anyway, see what happens. Yeah, you see my questions come, and you can actually then reply to that question. Basically, if it works. Oh, shit. It's kind of messed up. You see, this platform sometimes doesn't exactly work. There's definitely something wrong with that right now. But anyway, theoretically, you should be able to reply to the question and also answer your own questions. Now, notifications only happen. We've kind of turned off notifications except for when somebody replies to something you've written. So if one of you replies to my question, I'll get an email telling me somebody's replied. And if you probably just got an email now because you created this original document. You've probably just got a notification saying someone's commented on your document. So you only get a notification if somebody replies directly to something you did. Otherwise, there'd be too many notifications. And so what you will always actually see a question. But I'd just like to encourage you to all just try to use the platform, even if it's sometimes a little bit annoying. If something goes wrong, like with me just now, then just tell me. Then I'll get the IT. We've got an IT support team who react pretty quickly, and so they'll help. But let's really try to make an effort to keep all questions inside here. And what's nice about it is that you then, if you go to responses, you then actually see on the right here, like all the questions and all the solution responses that people have added to this document, which is a nice way of keeping it all together. And so what I actually want to ask you to do, instead of creating a new story like you just suggested in point number 3, to actually just create responses or questions on this document. So either you click questions to ask a question, or you click reply to create a solution description. And the difference is that if you click reply, it actually creates like a new, so you can create a document saying my solution, you can say blah, 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 you can embed Google documents, only Google documents. You can also insert links. You can actually make videos as well if you want. But if you save it, then what happens is that I then go back to the collaboration. You see that if I now go to responses, You can see also I've put the participant registration and the indication of interest survey on there as well. You can see my solutions come up here now, which is a really good way of keeping it summarized. You can delete stuff really easily. You can only delete stuff you've created yourself. You can't go around deleting other people's stuff. So it doesn't matter if you do something wrong, just delete it. So for example here, I can now delete it and then it disappears. Although just notice that that delete didn't have a question, are you sure? So be careful with that. So at the moment in these responses, you can see, you can get to the participant registration page. You can also get to an embedded summary of the Mentimeter survey that I just made, which I just put in, which is quite nice because you can see the results directly instead of having to go separately to Mentimeter. Yeah, so my request to you is to keep everything connected, all the documents you create connected to this collaboration. And that's basically it. So next step, sign up, have a look at the data, have a look at the challenge in general, and then in the next meeting, I think you will, as he said, will present some methods, and you can ask questions about any methods you might want to use. You can create a solution at any time as well, and it can be a draft. You can share code, on GitHub or whatever using a link. I'd just like to encourage as much collaboration as possible. Yeah, any questions? We've got 1 minute left, so
yep.
Any very quick questions? Someone's written something in the chat. Okay, Scott's got to jump on the train. Okay. You must have explained everything so well. I don't want to ask any questions.
I think it's after a long holiday and everyone need a bit time to kind of digest whatever need to be done, and so we'll take the time and hopefully next month and in early February, and we will hit the ground running and to have more substantial discussion. Sounds good. And those of you who know me know that I usually send update emails on Wednesdays. So probably this Wednesday, if you send me the link to the recording, I'll put it on Relight and then I'll send an email informing you all that the recording's uploaded, and then I'll see you in a month. I will do that later today. And then to have the slides, I see a couple of typos. I need to correct that before I share the slides. Okay. All right. Sounds good. Okay. Thanks everyone for coming, and you as well. Thank you for being. Yeah, thank you, Sarah. Okay, look forward to working together. All right, bye everyone. Bye. Thank you.
Thank you.
Thank you so much.